And essentially we started this as part of essentially like kind of a self-roast / reflection. You know, it's been 16 years since the first introduction of Bitcoin. There's been several billions of dollars invested in the industry. And we've had a lot of great things, but you know, the one thing is we still don't have Web3 apps, consumer apps that really stick. And we thought really hard about this, and we think, you know, the first principle for this is relatively simple and unified, which is, right, Web3 games and social applications and consumer applications today just aren't as good as Web 2 ones, right? Like Web3 games, they haven't really been able to surpass Web 2 games in terms of performance and playability. Same thing for social. Nobody's like really exceeded Instagram or Twitter in terms of user experience. And so at Nora, what we're building is your first companion to be able to finally build those applications that surpass Web 2 and Web 3 extremely easily. Under the hood, it's the world's first coding models built specifically for smart contract and blockchain code. And this is already surpassing Cursor and Claude code for Web 3 generated, Web 3 related generation tasks. It's also designed to be extremely logic rigorous and security aligned. So we're a team of essentially Web3 infrastructure builders and deep AI researchers, formerly working on projects like post-training reinforcement learning at DeepMind, and then also things like the Llama open source LLM model at Meta. And so this is kind of essentially what allows us to solve a few of these really critical problems that have been essentially preventing AI to break into Web3 up until now, which is Web3 code it's very logic rigorous and it's very security critical. And so we've been solving these with cutting edge reinforcement learning and then also mathematical formal verification methods. And the technology might sound really arcane, but the product is really built for everybody. So from seasoned Web3 devs to Web3 novices to even if you're just a casual user who doesn't know how to code at all. And people can build anything from advanced DeFi to on-chain consumer apps to engaging, close to AAA quality games. We've already had early beta users build things like explorations with advanced and more arcane methods of tick math, indexes, and then also fully on-chain liquidity provisioning protocols and whatnot. And so that's all been possible early on, and we're extremely excited. We're also very lucky since the month or so that we've deployed to have communities worldwide really helping us and joining forces. We've had over a dozen communities covering over 200K developers. And in each of the events we've covered so far, we've been able to average around 50% of the participants picking up and using. And yeah, don't just hear it from us. We're extremely lucky. We feel lucky and excited about the early feedback that our community is giving us. And yeah, for those who are excited about building in Web3 and really want to build the next generation of next billion consumer applications, follow us at mynora.ai and feel free to download us and take it for a spin. Yeah, thank you.
Okay, so greetings, Earthlings. I have my antennas, so today I'm in better connection to orbit. And yeah, we'll share about the expansion of the world computer vision into space. So we teamed up with a bunch of really high-quality people, including Dalia Malki, was the CTO of Libra, Facebook, chief scientist at Chainlink afterwards, one of the inventors of secure multi-party computation. So really good quality. My co-founder is a TE expert. And we brought the previous SpaceX VP as advisor just recently. And also, we might be hiring you if you look like an alien and you know some things about TE. So, brief history of computing. So, we started with the automation of computing with task-specific computers, and then Alan Turing came and expanded that to general-purpose computing. And briefly, after we introduced transistors and miniaturization, we ended up with the internet, which was fantastic. And then essentially what the internet provided us is the digitization of trusted party that comes in the form of banks or Google or other parties which we introduce and we transact through. And this was all really fantastic. We have a commercial internet. Until it wasn't looking really good because we had the bailout of the banks, and every time basically we get wrecked because we're not close to the Cantillon and the money printer. So then came the crypto economic system, which essentially it's a distributed form of trusted party. So just instead of a centralized trusted party, we have a distributed form of trusted party. And it's incentivized with tokens, game theoretic principles, as well as the cryptographic security for the data. Now, Bitcoin, kind of like the early version of compute, was a task-specific distributed computer, so it only serves for peer-to-peer electronic cash payments, or later landed on the gold use case, and then Vitalik came with the unicorns and expanded to the general purpose distributed computing. Fantastic. Now the question is, what did we have since Ethereum? We had cheaper network, faster network, more casino tech, and other stuff that really, I don't know if they really need to exist. So the question is, the world computer the final frontier? Obviously not. Now, in the last 2 years alone, we launched more satellite into orbit as species than in the entire previous century. So the cost to launch into orbit is decreasing. I'll skip because I don't have a lot of time. Now we can imagine very cool applications, one of which is to build a distributed trusted party based on satellite, so a space TE network. So the way that it works is that you have a TE network that serves for high security guarantees in orbit, serves for satellite services as well as Earth services. At zooming in on a single satellite, we interface into the compute via orbit port, the gateway for space compute, and essentially then can do the request for functions. Eventually we can distribute the gateways to the compute, and then it's kind of like a distributed RPC. When we are able to launch a constellation of those, then you have the constellation of space TE, essentially the layer 1 in orbit, and augmenting performance with the layer 2s on Earth, because the layer 1 in orbit is still capacity constrained, kind of like a slow Bitcoin style network. This is an example of how we are enabling one of the use cases today. We're harvesting cosmic radiation as a source for randomness and provide the randomness beacon. So essentially you're, as a user, requesting the randomness, getting to interface to, in this case, one of our partners' satellite, fetches it and gets into your application, which we had 2 examples here. One of them is a password generator that relies on randomness. Another one is a raffle application. And yeah, where we're at today is that we're starting to enable more features into the orbit port space compute gateways. And eventually, we want to see the ability to deploy contracts from space, which is kind of like international waters, so you don't need to be bounded to a jurisdiction. And further down the line, a celestial compute marketplace, so essentially general satellite services. And launch a full network. I'm kind of running out of time, so yeah, thanks a lot.
Hello everyone, GM, it's Pablo Shishi. I'm from Flowlink, trusted bridge between crypto transactions. So have you ever been in a situation where you needed to pay your employers money and you needed to involve crypto or stable coins? But then number 1, you don't know how regulations go. Number 2, you don't know how auditing goes. And even talking about copying wallets and other things are so difficult in terms of transactions. Flowlink solves it all. So we also had one story from Alan. So Alan is part of our team. He had everything in terms of scholarship to go to Germany, but Alan worked inside the crypto space, right? Because of that, his visa was denied. So usually when you go to Africa and you're trying to travel, sometimes in terms of visa, they ask you for bank statement. But then since he works inside the crypto space, there is no proof that he actually works in that particular space. So as an employer, before you get employed, the bank statement is more of like a proof that you're an employer. But because he doesn't have that, his visa was denied. And that is why we are building Flowlink. So it's not only Alan, it involves everywhere. Even my brother had the same issue. He was a student and he was supposed to travel. But because he worked in the crypto space, he was not able to get access to some of these things. So what he had to do was get the money from crypto, send it through his bank, just to show proof that he actually makes payments in the bank. And this involves also global businesses, remote workers, and DIOs who are having these issues in terms of making payments inside the crypto ecosystem. Now, what does Flowlink do? It's very simple. Number one, Flowlink makes payments very easy. So imagine having a payment without thinking of any wallet address or anything and just having a link to send to someone. And because we were doing auditing and compliance integrated with the help of HashKey, we just give you, so for instance, for Africa, we might not require KYC. But talking about Hong Kong and Singapore, you might require KYC. And we also have something called programmable compliance votes. So what happens is that you can be able to automate transactions over a large number of people. So let's say if you're talking about enterprises who are like working with each other, they can be able to use the compliance votes. Also, we have something called reward asset subscription and cross-border payment rails. And we are looking at Africa and then Asia. The reason is that our company is full of people from Asia and people of Africa. And we are looking at Uganda, Ghana, and then Nigeria. In Asia, we're looking at Hong Kong and Singapore, since HashKey has a lot of presence in Hong Kong and Singapore. And Flowlink is in two ways. So one is the front end, and we are still building the app, but then the web app is ready, and you can try it out. And we are building what we call Proof of Link. So Proof Link is an integration to other applications. So we are partnered with an application called Ccash. Ccash is a cross-border payment. In Africa, cross-border payment is one of the hugest markets in terms of stable coins. And what they do is that they send money from USDC into their local currency. And they are based in different particular countries. And that is what we are planning to do. So Proof of Link can be integrated in that payment system. We are also looking at other corridors. So as you can see, we are looking at Africa, which is Nigeria, Kenya, Ghana. I have a bit of experience in fintech in terms of African countries, including Francophone countries. And so we are looking at that sector. And we're also looking at Asia, which is Hong Kong and Singapore. And now look at the target on here. So right now, we are looking at 450 billion amount in terms of the target market we are having, talking about global businesses, financial institutions, Web3 organizations, and stablecoin issuers. And this is our business model. So already we are taking 1.4% to 1.6%, depending on the transaction. We are also looking at future revenues like Proof Link. So for instance, if Ccash is able to successfully integrate our application into the application, we take a bit of fee on every transaction that they do. Now we're looking at the competitive landscape. As I said, it's very easy to use Flowlink. You don't need to be a crypto user to be able to use Flowlink. Now, this is the technical architecture, and this is our roadmap. Already, we have our web app. We're looking to have a mobile app because our focus is not only crypto users. We are also focused on non-crypto users. So imagine having maybe a stable coin, and you can be able to send money to someone in maybe its local currency. And already, there's a platform like Ccash already doing that. And then why now? As you can see, from 2020 to 2025, stablecoin has moved to 200 billion. And this is a market that we are actually looking at. And already we are talking about local stablecoins, which already platform has integrated and already. And if you talk about Africa use case, cross-border payment is one of the biggest markets in Africa. And this is our team. I'm Pablo. I'm a researcher. I have 4 years in the crypto space. I've also been involved 1 year inside the fintech industry in Africa. And we have Akash, who is a former Google intern. And our founder, who is also Samuel Danso, who is taking care of our design. Yeah, thank you so much. Yeah.
Hi everyone, I'm Okaris. So I'm gonna talk about Arceo. Basically, it's the Palantir of the Global South. So the idea is to focus on sovereign AI deployment on countries across the globe. So sovereign AI is an AI that reflects the culture of specific regions of the world. So for instance, ChatGPT can speak a lot of languages, right? So we can think of it as a polyglot, right? But if I'm American and I speak Hindi, it doesn't necessarily mean I think like an Indian person, right? So sovereign AI is having an AI that actually understands the cultural nuances of different regions across the globe. Okay, so in terms of my background, I've been a researcher, nerd for quite a long time, mainly researching in AI. And I kind of organically ended up advising some companies trying to develop their own sovereign LLMs in Central Asia, and this is how this idea came about. I've also done a lot of optimization on trying to do fast image and video generation, so that helps a lot as well when you are trying to host AIs in bad hardware, because you can do the similar optimizations for bad hardware in the global south. So basically, kind of the idea is that 90% of the global compute is clustered in the US and China, right? So for you to actually have sovereign AI, it's not only a matter of training the AI in your local culture and language, you also need to be able to host it in your country, right? Because at the end of the day, if the AI lives in a data center, which is in some foreign country, it's very hard to control how the data is used. They can shut down your AI, right? So we need to find a way also to, apart from training the AI in the local culture, host it locally. And that's particularly relevant right now. Why? Because of export controls, it's becoming harder and harder to actually build your data centers, even if you did have the money. Then there's a lot of countries like the EU, India, and many more that are actually really focusing on this kind of regulations, trying to keep their data safe. And at the same time, we are seeing this geopolitical tendency of a lot of smaller countries in Central Asia, the Caribbean, South America, trying to actually develop their own AIs. So I'm not trying to reinvent the wheel. There's already a lot of interest for this across the globe. The main question is, once you actually develop your AI, how do you actually use it in practice, right? How can you deploy it to the people when you don't have big data centers? So basically what Arceo does is it takes the default sovereign AI, so we work with the government and local companies to develop the AI, right? And think of it as the default architecture. We know how the brain thinks, right? But then to fit that brain into a CPU, into a GPU, or into an Apple M series at low level, it's actually functioning slightly differently. So what Arceo does is it has a universal adapter layer. You download it into your computer. It analyzes your computer, and then it compresses the AI to fit inside your computer optimally. And then basically we are going for a core offering plus verticalization platform in which the actual optimization is universal, and then we work with different governments and financial institutions across the globe to train it specifically for their own culture. But yeah, you can expect different ministries, for instance, in the governments may have different requirements. So if I'm a financial institution or the central bank, maybe I need to be able to access also Excel files, right? If I'm in education, like the Ministry of Education, maybe I need to be able to retrieve information from books that different kids and people in universities use, right? So you need to tailor the platform slightly, but the core optimization and agentic features can be shared for all use cases. And yeah, then we can look, there's other competitors. So for instance, there's local LLM platforms that some people may have used, like Olama, LM Studio, etc. But this is mainly for people like us that are interested in technology, right? So they have a lot of different features that one needs to set manually. So you can imagine if you're an employee in a government, it's kind of hard to play with all of this. So what Arceo does is it just optimizes everything in the backend for you, and we only host one AI. Because we only host one model, we can do much more optimization than what, for instance, Olama can do, because it's just a one-size-fits-all kind of platform. Whereas in our case, we control exactly the closed source AI that we are downloading, and we have specialized kernels and low-level optimizations for that. Yeah, and then other AIs that a lot of people use, right? We are all familiar with this. The problem is it's hosted in an American data center. It filters all your data, right? And it's not a good advisor for governments across the world, because basically it has this American view, right? Or there's other Chinese alternatives which are trained to think like a Chinese person. Ideally, you want an AI that aligns with your culture to make decisions in your country. So here we are trying to decentralize AI in that sense. Yeah, in terms of traction, so we have influence at the source, right? Because basically there's already advisory roles at different companies trying to develop these AIs. So now it's a matter of deploying them into the real world. And we have some pilots that are soon to start in Central Asia. So again, we are not limited to Central Asia. There's also interest from South America, Africa, and Southeast Asia. We are just trying to get the initial pilot there, show how we can deploy into a country with low resources, and then scale to the rest of the global south and across the globe. Okay, thank you.